In this video, we will do further problems from exercise 3.9. Question number 8. In a triangle ABC, prove that a squared minus b squared plus c squared within bracket times tan b is equal to a squared plus b squared minus c squared within bracket times tan c. We know that cos b is equal to a squared plus c squared minus b squared divided by 2ac, which implies that if we take this term here, which is a squared plus c squared minus b squared, and rearrange it, a squared minus b squared plus c squared, and take the 2ac to the opposite side, then this becomes 2ac cos b. Right. So this is the same as this term here on the left hand side. So our left hand side will be equal to, let's replace a squared minus b squared plus c squared with 2ac cos b, 2ac cos b times, then you have a tan b. So instead of tan b, let's call that as sin b divided by cos b. So here cos b and cos b will be cancelled. So you will be left with 2ac sin b. Now we know sin b can be rewritten as b by 2r. So this is 2ac into b by 2r. 2 and 2 will be cancelled. So you will be left with abc divided by r. So let's call this 1. Similarly, we know that cos c can be written as a squared plus b squared minus c squared divided by 2ab. So this implies a squared plus b squared minus c squared is equal to 2ab cos c. Let's apply this onto the right hand side. So our RHS will now become, so instead of a squared plus b squared minus c squared, the first term here, we will replace it with 2ab cos c. So this becomes 2ab cos c times tan c. So instead of tan c, let's call that as sin c by cos c times sin c by cos c. Again, cos c and cos c will get cancelled. So you'll be left with 2ab sin c. Again, sin c can be rewritten as, let's keep the 2ab as it is. Sin c will become c by 2r times here. 2 and 2 will get cancelled. So this is equal to abc by r. So let's call this 2. So from 1 and 2, our LHS is equal to RHS. Hence the proof. Question number 9. An engineer has to develop a triangular shaped park with a perimeter 120 meters in a village. The park to be developed must be of maximum area. Find out the dimensions of a park. So we need to design a park, and the shape of the park is a triangle. So let's consider this triangle A, B, C. So this has angle A, angle B, and angle C. And the sides can be defined as small a, small b, and a small c. Right. Now, what is given to us is that the perimeter is 120 meters, which means A plus B plus C is equal to 120 meters. Now, according to geometry, this is a very simple problem. Geometry states that if you're given the perimeter, the maximum area that you can get by designing a triangle using these dimensions is only when all the three sides are equal, which is an equilateral triangle, which means A will be equal to B, that will be equal to C. In this case, that should be equal to 40 meters. So this is a very simple problem to solve using geometry. However, this question is not related to geometry. This is related to trigonometry, and in your example problem, they have tried to use Heron's formula of area. So what does Heron's formula of area says? The Heron's formula says area of a triangle ABC is equal to square root of S into S minus A into S minus B into S minus C, where your S is equal to semi-perimeter, which is A plus B plus C divided by 2. In this case, your S will be 60, 120 divided by 2, which is 60. However, we'll keep the S as it is right now. So, you have to solve using the Heron's formula. So, we will not use geometric application. We will use this formula and try and solve this problem. Now, how can this root of S into S minus A into S minus B, S minus C have a maximum value? S is a fixed number. You can see that it is 60 here. So it is a constant. The only thing that can vary is your A, B, and a C, which means these three values can change, or A, B, C can change. So to get a maximum value, you need to get the maximum of S minus A into S minus B into S minus C. We need the maximum value of this product here. The way to solve this is already given in your example problem. However, I'll explain that over here. Now, we can build a relationship between geometric mean and arithmetic mean. Let's say we know that the arithmetic mean is greater than or equal to the geometric mean of any three numbers or any number of elements. Okay, so here, what is the arithmetic mean of these three? The arithmetic mean of these three will be S minus A plus S minus B plus S minus C divided by 3. And what is the geometric mean of these three? Geometric mean is, so let me keep this. This is the arithmetic mean, has to be greater than or equal to the geometric mean. So let me put the geometric mean here. Geometric mean would be, let's put the product S minus A into S minus B into S minus C to the power 1 by 3. This is the geometric mean. So from this relationship, we can say that our S minus A into S minus B into S minus C will be less than or equal to, if I'm making this as a a cube on both the sides. So this 1 by 3 will become to the power 1. This will become, the numerator will become S minus A plus S minus B plus S minus C to the power cube divided by 3 cube, which is nothing but 27. Now this S minus A, S minus B and S minus C, as you can see, is nothing but So let me keep this sign here as it is. This is 3s minus, there's a, b, and a c. So let me put them within bracket, a plus b plus c to the power cube divided by 27. So this further, a plus b plus c, we know from here that s is equal to a plus b plus c by 2. So a plus b plus c is 2s. So this is nothing but 3s minus 2s to the power cube divided by 27, which means this is 3s minus 2s is s cube over 27. So now we have, using the geometric mean and the arithmetic mean relationship, that our s minus a into s minus b into s minus c is less than or equal to s cubed by 27. Another thing that we need to understand here is, it's given in your example, that when you're given x, y, z as a product, its maximum value, so the maximum of x, y, and z occurs when x is equal to y is equal to z, and this is already given in your example problem. So from this we can say the maximum occurs when s minus a is equal to s minus b is equal to s minus c, which this can happen only when a is equal to b is equal to c. So now let's take this relationship, and let's assume that our b is equal to a and c is equal to a. So the left hand side now becomes s minus a the whole cube, that's less than or equal to s cube divided by 27. So this implies that our s minus a is less than or equal to s by 27. Sorry, it's s by 3, because 3 cube is 27. So you need to take the cube root of both sides. So it's s minus a is less than or equal to s by 3. So from this, let's substitute the value of s. So this s is equal to 60. So this becomes 60 minus a is less than or equal to 60 divided by 3. So further simplifying this, 60 minus a is less than or equal to 20, which implies our a is greater than or equal to 60 minus 20, which is 40. Therefore, the sides of the triangular park is 40 meters. That is, our A is equal to 40 meters, B is equal to 40 meters, and C is equal to 40 meters from the triangle here. Question number 10. A rope of length 12 meters is given. Find the largest area of the triangle formed by this rope and find the dimensions of the triangle so formed. So the perimeter is now given. The perimeter of the triangle is equal to 12 meters. So this is the triangle. This is A, B, and C. A plus B plus C is equal to 12 meters. So this is given to us. Now, the largest area is obtained when A is equal to B is equal to C, which means when this is a equilateral triangle. So for A to be equal to B to be equal to C, we can see very clearly the side of the triangle will be equal to 4 meters. 12 divided by 3 will be 4. So we have the side of the triangle. Now we need to find the area of the triangle. The largest area. Because the area of using 4 meters as each side will give you the largest area of a triangle formed when the perimeter of the triangle is 12 meters. So the largest area of the triangle, let's use the Heron's formula, and so that's equal to S into S minus A, S minus B into S minus C, where S is the semi-perimeter, which is A plus B plus C divided by 2, which is equal to 12 by 2, which is 6. And here our A is equal to B is equal to C, which is all 4, 4, 4. So here let me say within bracket Heron's formula. So substituting the values, 6, S minus A is 6 minus 4 into 6 minus 4 into 6 minus 4, which is nothing but, this is all 2, 6 into 2 times 2 times 2 times 2 will be 8, root of 6 into 8. So this can be written as root of 3 into 16k. So that is nothing but 4 times root 3. So this will be the largest area that we can get, and the unit would be square meter. Question number 11. Derive projection formula from using first the law of sines and second the law of cosines. So let's take the first part, which is the law of sines. Okay, so the projection formula is nothing but, or let's say we need to prove the projection formula, which is A is equal to B cos C plus C cos B. So let's take the right hand side. So the right hand side is equal to B cos C plus C cos B. So we are being asked to use the law of sines. So according to the law of sines, B can be written as 2R sine B, and we retain the cos C, plus C can be replaced with 2R sine C, and cos B, let's retain it as it is. Now let's take the 2R, which is common outside. So this is sine B cos C plus sine C cos B. Now this is in the form of, let me put this 2R here outside, sine B plus C. Again, B plus C can be written as 2R into sine pi minus A, because we know that A plus B plus C is equal to pi. Therefore, B plus C is equal to pi minus A. Right. So sine pi minus a is nothing but sine a. So this is 2r sine a. Again, sine a, 2r sine a is nothing but a, which is equal to the left hand side. Therefore, the proof. Next, let's try and prove this using the law of sines. Sorry, law of cosines. Law of cosines. Okay. So again, we need to prove A is equal to B cos C plus C into cos B. So let's take the right hand side now. So the right hand side is B cos C plus C cos B. Let's replace cos C using the cosine law. So this is B into, according to the cosine law, cos C is nothing but A squared plus B squared minus C squared divided by 2AB. Similarly, cos B will be A squared plus C squared minus B squared divided by 2AC. Again, B and B will get cancelled. C and C will be cancelled. So 2A is a common denominator. So we keep the 2A as common denominator. And in the numerator, we have A squared plus B squared minus C squared. And from this side, right side, it is A plus A squared plus C squared minus B squared. B squared and B squared will disappear. C squared and C squared. So you're left with 2A squared divided by 2A. 2 and 2 will disappear. A and 1A will go. So you're left with A, which is equal to the left hand side, hence the proof.
Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.